This week, we're going to talk about phytoplankton. My little saying that I'm going to start with is that when the leaves are on the trees, the whales are in our seas. Now, that is not a coincidence. It is the growing season on land and in the ocean. So if you think about plants on land, they photosynthesize. They take carbon dioxide and water, and with sunlight and nutrients, they're able to create sugar and release oxygen. Well, in the ocean, they're doing the same thing. Those phytoplankton, those plant drifters, phytoplankton, are taking in the carbon dioxide and water. They're making sugar, which is really the energy that animals need to grow or to function. So it's taking the light energy from the sun and turning it into chemical energy that other organisms can use and releasing oxygen in the process. Now, the way they're getting nutrients, there's two ways in the ocean. These phytoplankton float at the surface so that they can capture the sunlight, but nutrients sink. So one way is that as the nutrients or as the currents are moving along at the bottom of the water column, they hit sometimes these underwater mountains in the ocean. It comes up and it brings those nutrients up to the surface. So there's a lot of sunlight, a lot of nutrients. We get a lot of phytoplankton. Another way, it's a little more disgusting, but it's from the whale's poop. So here's a quick video to show you an animal pooping. But they often poop at the surface. And so that also puts nutrients into the ecosystem that those phytoplankton can use in order to photosynthesize. So we think that the ocean is producing more than half the oxygen on our planet. So it's really important that we keep this ocean healthy. And all of these phytoplankton, even though we can't see any of them with their naked eyes, they are such an important part of the health of our planet. So we wanted to share with you what some of these plankton look like. So here's some diatoms, okay, in different shapes. And then sometimes they'll have spikes. You know, you think about when you float at the surface, your arms are out to the side. It helps you stay close to the surface. Sometimes the phytoplankton are linked together and form these chains because that also helps them float at the surface. Now, this is a serratium. It's a type of dinoflagellate. So they have a little flagella. You can see them moving here, a couple. But this is the flagella. If you look in the red circle there, you can see the flagella moving. That's how they're moving through the water. So look back at this video again. You could see a few of them. These are two different species of dinoflagellates that are moving through the water. And the rest of those things are all different types of phytoplankton. And then this is one of my favorite pictures because look at all of the different shapes. There's some corkscrews, there's some circles, there's some chains, there's some arcs, there's all different kinds of phytoplankton in this picture. So I've been doing plankton toes for years, and the serratium are the most commonly cited phytoplankton when we're watching whales. This year, though, in the last month and a half, we've had these radiolarian. So this is what they look like. They're red when I put them under the little discovery scopes, but the microscope that I took the picture from doesn't pick up the redness, but you can see the little serratium that just moved in. It was powerful enough to move that radiolarian. Not really sure what they're all about and how they've impacted the ecosystem out here, but I'm hoping to find out sometime. So that's it for these little powerhouses of the ocean. Stay tuned to see what's up next week.